हैप्पी बर्थडे। ठीक है,
थैंक्स।
ओके बाय। मैं बस थैंक यू so much. Okay students, so we'll be starting it. Okay, I've started the live streaming. How is everyone? What about YouTube students? Enjoying the days? How is everyone? So it's live, no? You know, let me close this thing. Okay. Yes. Is the voice fine now? Abhi voice ठीक है? Is the voice fine? Okay, I'm launching this poll. Don't worry. Don't worry, students. Everyone is important here. So let me launch the poll. Yes, master. What are you texting this master? Okay, hold on. Let me. Where's this poll thing? And the polls are there. What? Okay, no issues. I'm audible. Then fine. Video bhi dekh lo meri. Okay, fine. Now 10 students have joined. Shoy Merchant, Sweetie, Kadi, Madiha have also joined. Okay. And rest of the students are Suman have also joined. Cool. Okay. To first see what's the strategy. Let us not waste the time. 6:47 it is. So everything is clear. My audio is also good, and everything is fine. Okay. So strategy क्या है? आप ये देखते हैं रुको. Good evening, Suman. Good evening. देखो आप good evening छोड़ो. Like leave this good evening and all these things. Let us start the class. Okay. Let me put this spotlight. Okay. Yes, I'm starting it. See, what is strategy? Strategy is this. Today we'll be having just a friction session. Okay, I'm in numerical session based on the topic which is friction. Friction is the second part of what? NLM2. Fine, है ना? ठीक है? Very good. अब start करते हैं. See, these are the contents of today's class. Video मैं बंद कर रहा हूँ. Technical errors नहीं होनी चाहिए. Okay. So you can see this contents on your screens. I'm going to launch it now. See, the contents are these. Introductory numericals, then concept-based numericals. Okay, and based on the chapter, which is our friction. Got it? Got it, students? Yes or no? अब तो समझ में आ रहा है ना? Everything is clear, no? ठीक है? Introductory numericals. Let us see again this animation. Then first we'll go through introduction numericals and concept-based numericals after that. Okay, but based on what? Based on this, that is friction topic. Friction. Okay. So are you ready? Yes or no? Are you ready or not? So are we ready? Yes or no? Are we all ready or no? Yes. Okay. Yes, master. Master board like Lucy. Okay. So now let us start it. Okay. See, this is the first question. This is a question for you. I have put here this second clock also. Okay. So it's working here. So just read this question and answer it. Read this question and answer it, students. Oh, A and B are not the options here. There you have to give the direction. Where will be the direction they're asking you? Direction किधर होगा? Okay. See it carefully. This on the block exerted by the ground. See, the question is this. This is a block. Okay, I'll be solving now. Don't worry. I'll be solving. Okay. So you can see here, this is block of mass. How much kg? 1 kilo, 1 kg. External force F equals to 1 Newton is acting in this direction. And you know, this block is moving towards this direction, which is 5 meters per second. And at A part, they're asking us to find, all the students are answering, yeah, Uttarakhand students, JNV Uttarakhand students have given the right answer. Excellent. So in the A part, they're asking us that on the block, find the direction of the kinetic force on the block exerted by the ground. Block के ऊपर जो ground force exert कर रहा है, वो we have to find. Then on the ground exerted by the block. Simple है. Let me draw this question. ठीक है? Got it. So suppose we are having a line like this. This is a platform. I made it a bad here. Like this. No. This is fine. Okay. Now suppose this was the ground. Okay. And the block is on the ground like this. The block is on the ground. This block is having the mass m. Okay. And there is a friction on the ground. External force is acting like this. And velocity of the block is in this direction. Okay. And they're asking us in A part, find the friction force exerted by the ground. Of course. So how you find the direction of the kinetic friction? And they have not only given the friction force, they have written there kinetic force of friction. You must remember this thing, that wherever there will be a sliding, kinetic friction will act. Kinetic friction will get generated there. Okay. Wherever there is a sliding case, kinetic force of friction will come into play. Okay, play its role there. So see, what I'm going to do here is this. Here the kinetic force will be where? It will be, yes, opposite to the motion of the block. Is this the thing? Yes, the force will be opposite to the motion of the block. That is friction force. Let me show this with red color because red is something which is like a resisting here. So friction force F will be here. Okay, and it is opposite to the direction of what? If you write it in the equal to sense, it is negative of the velocity vector direction. Okay. F cap is equals to minus of V cap. These are the things. This is the A part. That is, it is applied by the ground on the block, and then block by the ground, and by the block on the ground. Kis direction mein hoga? By the block on the ground. It's B part. That will be, it's actually same in the direction of F cap. Like friction, which is by the block on the ground, will be looking like this. Is it fine? Yes. So we have solved both the answers. So on the ground, it will be in this direction. On the block, it will be in this direction. Okay. I have seen some students have given the right answer. So you can match with this. Okay. So this here we completed our numerical number. This is our numerical. This is which numerical? See, by the way, how are you everyone? Like, are you having any doubts? Are you having any doubts? I mean, related to friction theory. This question is cleared, 100%. Numerical number 1. Okay. Okay, now let us take a cool question. Okay, that is also based on previous question only. But leave that, okay. They're asking us, okay, solve this question also. That friction force by the ground on the block. Okay, by the ground on the block, say we give it value as F1. And friction force, this is by the ground on the block. And friction force, say F2, which is by the block on the ground. Okay. So what do you say? What are the values? A, B, C, or D? Now options are there, students. Now you can text it. What are the options? A, B, C, or D? B. B? I don't think so. B. I don't think so. B is the option. F2, you say F2 is greater than F1. You say here F2 is greater than F1. I think it's an action reaction pair. No. Some say A. How you can say? Can you text me the reasons also? Can you students text me the reason also? What the reason is? Reason क्या हो सकता है? Nobody is texting C. I think C is the answer, isn't it? So in this case, if you're taking F1, F2 as the cases, of course, these are action-reaction pairs. Okay. If the block, if the ground is applying the F1, ground on the block is applying F1 in this direction, the block will be applying the same force, but in the opposite direction, reaction pair it is. So we'll say F1 in magnitude sense will be equals to F2. So most appropriate answer is C. Is this thing wrong? Most appropriate answer is C. Got it, students? Yes or no? Text here, yes or no. I hope it's cleared. Okay. I hope this thing is cleared now. I hope this thing is cleared. Yes. So let's see what is happening on the YouTube. Let me see 1 second. Let us see, is it live on YouTube? No. Yes. Let me see. Just wait a second, students. Okay. Just wait for a second. Just wait for a second. Yes, it's there. Fine. Cool. Let's move back. Okay. So let us move towards the next question now. Yeah. So this is also a very beautiful basic level question for you. Solve it. So here it is given that all the surfaces are rough. All the surfaces are rough, and draw the friction forces on A and B. Okay, picture is in front of you. Okay, JNB Davanagar students have given the doubt key, sir, if the object is moving, then the friction force will be overcome. So how they will be equal? Don't think like this. So you're taking it wrong. Let me explain. Students, do you want from me to like explain you about the friction force again? One student have asked the doubt, and this is really appreciable doubt. The reason, because see, if one of you among is asking the doubt, other students are also being helped. So the doubt is this: if the object is moving, then the frictional force will be overcome. It doesn't make sense. So how they are equal? Sir, it is doubt. Do you want me to explain friction again? I mean, somewhat of the theory parts. Yes or no? Okay. Before solving this question, let us see. Okay. See, one thing you must clear in your mind, that it's nothing to overcome. Okay, so we need. Okay, that's fine. See, suppose there is a surface like this. Okay, let me draw it in front of you. Suppose it is this. Now you can focus on the screen. Focus on the screen. Okay. This is a surface. If a block is present on the surface, this block is having the mass m. M mass ka block hai. And if I apply the force F, and suppose the surface is friction, I mean, it's like, rough surface, rough. Mu is a coefficient of friction. I don't know static, kinetic, whatever. Okay. You know this thing, if this block is moving, ground will be applying a friction force on it, which is equals to mu into n, where n is the normal reaction, is equals to mg. You know this thing, no? So we'll say here, if this is moving, are we writing like this? F is equals to mu n. Where we have written this thing? Are we writing like this? F is equals to mu n. No, never. This shows like this, this block is basically counterbalance, or two forces are basically balancing each other. That is R applied external force and frictional force by the ground. So this will be in equilibrium. But if we want its acceleration, we'll say F equals to mu mg, mass times acceleration. Friction force is overcome. That's fine. Overcome doesn't mean this block will not move. This block is moving. And there in that question, they're asking us individually that if the block is there, it is moving with some speed, say 5 meters per second. I will generalize this question. And the mass is m, and the external force is acting here. So listen here. something which is moving with the constant speed like this, and suddenly a force is from here, it will reduce its speed. Plus, the motion is here, and roughness, of course, roughness is maintained. I mean, this platform is rough. Also, the base of this block is rough. Some mu coefficient of friction is there, leave kinetic, static, whatever. But since this block is moving, contacts will not be made with the platform. Also, one force is against the velocity vector of this block. So two forces will be there because it's moving here. So contact will be not so much. So we'll use here kinetic coefficient of friction and into N. That will be frictional force here. That is mu Kn. This is by the, see, this is the initial scene, recent scene, now scene. I mean, when you're seeing. Finally, the things will be different. Finally, see, friction force will be in opposite direction. It will add with this force, mu Kn, and will provide a big amount of deceleration to this block M, and the speed will decrease from V to 0. So scene will be like this. This is a block. This is moving like this. Finally, it will come to 0. Now, if still the external force F is acting, so it will now accelerate under this force, capital F. Now the friction will be in opposite direction. Again, it will be against the force now. Maybe first mu s will arise if it's, mu s is balancing it. If the force is greater than mu s, it's greater than, it's overcoming that, then again kinetic friction will come. I think this theory is clear to you. So we'll say here friction force is action reaction if mu Kn initially is here. So if it's from ground to the block, from the block to the ground will be here. Same magnitude F2 mu Kn. Action reaction, friction forces are action reaction. Every force which is in contact. See, let me tell you this thing. This is what? Block, mass M. This block is kept on this surface. It's in contact. What are the contact forces? Two contact forces which are arising. These are this. One is normal reaction. Actually, this is not actual force. This is the component of the contact force. But still, okay, let us take. So two forces are there. One is normal reaction, which is always present when the two things are in contact. Normal reaction shows us how much the two things are pressed together. So this will be action reaction. If from the ground to the block, it's like this. So on the ground, it will be N like this. Action reaction. Let us assume if the block is moving, so friction force will come into action, and this will be in this direction from the ground to the block, and from the block to the ground reaction, it will be in this direction. If we are considering this normal reaction force, we know this thing. It is what? Opposite in direction, but action reaction, same in magnitude. So if you are marking it N1, N2, I know this thing. This is magnitude sense, it is same. Same I apply for this. If I'm marking it as F1, F2, we know in magnitude sense it is same. Is the doubt cleared? Students, doubt cleared ho gaya? I hope JNV Chitradurga students, doubt was there. I hope it's cleared. Is the doubt cleared? Yes, very good. Madiha is also saying cleared. Very good. Devangiri, yes, sir. Cool. Okay, so let us move towards now this question. Now you must answer this question if the doubt is clear. देखो इस question में क्या हो रहा है? If you see it, I've closed this. Okay. The two blocks are there. They're in contact. See, यहाँ पे normal कुछ और होगा. यहाँ पे on the platform the normal will be somewhat different. But both the blocks are moving. But the downward block is moving with some more speed. Say 20 meter per second. The down block is moving with some more speed, that is 20 meter per second. Okay, 20 meter. And all the surfaces are rough. What does it mean? It means this is also having some mu friction. This is also say mu1, and this is also having some mu2. I mean, the contacts between the two blocks is also what? Rough. So you have to draw the friction force on A and B. You have to draw the friction forces on A and B here. Friction forces kya hoga? You have to see here. What will be the friction forces? Friction forces. Just give me the direction. X-axis, negative x-axis. What do you see? Okay, I am solving. So see. Okay, one student have texted. Let us see. It will be opposite to the side of the velocity. Okay, that's the case. Let us see, is this answer right or wrong? See, the question is like this. This is the platform. It's not an Indian Idol platform. Okay. This is what, this is block, and this is some A block. Up ऊपर वाला block is B block. These are two brothers. Okay, they are always together. But this is somewhat slow, and this is somewhat high speed. It's a high speeder. Okay. Now what's gonna happen? If these two blocks are moving, they're asking the friction directions. ठीक है? इसको कैसे देखेंगे students? How to analyze this problem? How to analyze this problem? It's like this. I'm not having pink color here. Let's take bluish. See, if you focus here, अगर आप focus करोगे, नीचे वाले block को अगर आप लेते हो, this is moving with what speed? It is moving with the speed of 20 मीटर पर सेकेंड. We'll say VA का speed magnitude ज्यादा है VT से. Agree? ठीक है? So suppose if you are having, this is a block, this is your block, दिख रहा है ना block है, ठीक है? This my hand is A block, big one. I mean a block which is moving with what, some more speed. And ऊपर वाला क्या है? It's a B block. If my hand is moving with more speed, it shows what? That this A block platform will slide first. ठीक है? A block platform will slide first. ठीक students? So this platform, which is A blocks, will slide first because it's having more speed. 20 is greater than 10, and it's twice of, it's twice, double it is. Okay. So I will say this A block will try to move first, will try to cross the B's base. है ना? It will be ahead. So B will try to stop it. So it will apply a friction force. So it's a friction force from B on A. From B on A. Also, the A block is moving on the ground. So ground will also apply a force Fg on A. These are all friction forces. Okay? So on A, if I see, just focus here. On A, if you're watching, A पे जो friction forces होंगी students, this will be like this. FB is not Facebook, FB on A and force on B. So force by B on A, force by ground on A. This is the FBD of A block, and final in like forward velocity is 20 meters per second. If we see about the B block की बात करें, I will say like this. B block पे, see this B block is पीछे. If this is applying the force on A on like this, इसके ऊपर क्या force लगेगा? In this direction, that is force on B, force by A on B. ठीक है? Only this much, only the friction force will act on this. I mean, there will be no two components. I mean, दो forces नहीं होंगी like this with the ground. जहाँ पे contact points, so this here the ground is having the contact point, so it will also apply the force, and this is also contact point, so this will also apply the force. But यहाँ पे तो एक ही है ना B block के लिए. For the B block, only one contact points, like contact lines are there. Okay, so that's why only one force will come into action. Clear हो गया ये question? Right? Yes or no? Text in the chat box. If you will text, then only I can proceed. No. Okay, good. What about other? What about other? Sorry, other students. Okay, then solve this question. Fine. Okay, not now, not this one, but for you people, for now, solve this. ABCD options are there. What do you can say? What is the answer? Sweetie says understood. Janvi Devanagari student says yes. Madiha says yes. Cool. Solve this question for ABCD option. ABCD के लिए करो solve. 61 number question. I'm waiting. Solve it. You are having 2 minutes. Clock is already started. Okay. Students, this clock is a 5-second clock, okay? You can see at 55 seconds, it switches back. Okay, but I'm counting the seconds for you, okay? Mark the options A, B, C, D. One student have texted, let me see. Okay. So few students have texted the answer. Let us see what are the solutions here. Madiha B, Sweetie C. Okay. See, I'm solving this. See, here it says, if you see the question properly, a monkey of mass M. This is what? A monkey of mass M. Climbing a rope hanging from a roof with an acceleration A. Okay. The coefficient of static friction between the body of the monkey and the rope is mu. The coefficient of static friction is what, students? Between the monkey's body and a rope is mu. Okay. Find the direction and the value of the friction force on the monkey. This is the question. Okay, I'm solving it now. Just please be focused on the slides. Okay. Just wait a second. Okay. Just wait a second. I'm coming. I'm like closing the door. Maybe unnecessary noise is coming. Maybe unnecessary noise is coming. Okay, so अब करते हैं solve. Okay. See, I'll draw the FBD here only. So please be very much focused. देखो tension कैसे लगती है? Tension, if there is a string which is say it's fixed under some kind of bars or walls, and this string is in what condition? It's a taut condition, खिंची हुई. We know this thing कि for spring tensions will be like this. Okay, tension acts in the spring. Students, don't make noise. Tensions act in the string in such a manner that it will try to what? Slack the string. This we know. Tension is acting in such a manner that it will try to slack the string. क्या करेगी? It will try to slack the string. ठीक है? So here also the tensions will be acting like this. If I draw the FPD of this, okay, इसमें पूछा कैसे, asking that if the monkey mass is climbing a rope hanging from the roof at this, the coefficient of static friction is this. So simple. Let us treat this monkey to be in equilibrium. Okay. So I will say like this. If this is M for this monkey G, so I will write here tension up. This is mg. This is the mass of this person. Okay. This is mg. This is equilibrium condition. Okay. This is what? Equilibrium condition. Here it says it's moving with acceleration. So if it's moving with acceleration, so the conditions will be different now. Let us say, again, I have to draw. This is what? Okay, that monkey is there. If it's moving with acceleration A, okay, tensions कैसे लगेगा? Tension force is acting like this up. Mg is the gravitational weight. I mean, it's the weight of this monkey. Tension is like this. Up, they are saying coefficient of static friction is the friction coefficient which is between the what hands of the monkey and the string. So it will also give him what a lift, a ability to what easily climb this string. Okay, so let us see it. ये पूछ रहे हैं what is the value of the friction. See, if you focus here on the slide, this is the hand. Okay, so normal reaction force कहाँ होगी? Normal is what? Basically friction. See, we are not considering here normal. Normal will be perpendicular to the contact points. Okay, but if we talk about friction here, friction force will be what? Acting with the tension force here. Okay, see, because monkey is, hold on, simple. So you are saying CF equals to mg. No, that's not a friction force. So friction will be acting as a positive factor for this monkey. Now if it's accelerating up, okay, when the thing is accelerating, so let me show you the demonstration. See this. Where's my video here? Yeah. See, if I just suppose this is the monkey's hands. Okay, if the monkey is doing like this, so what actually we are doing? I am pushing the string which is ahead of me down. I'm pushing it down. So in reaction, string will push me up. Which is that force? See, why I'm able to push this string? Because due to friction between the contact points of my hand and the string. Remember this thing. Why I'm able to, suppose I am climbing in place of this. I am climbing in place of this. So what is happening? I'm applying a force which is like which force? Which is the force? This is the contact force between the string, between the rope and my hand, and I'm pushing like this. Okay, in reaction on me, the force will be what? Up. So the friction force will be up on this monkey. Okay, so we'll write like this. Students, please mute yourself. Students, please mute yourself. Okay, I am then removing this. Who is this? If I will say friction force, it will be what? I'll say it is up. So now equate it, you'll get the answers. ठीक है? You have to equate this, you'll get the answer. Friction का value पूछा है. Direction, the value of the friction. Direction will be of course upward. Value will be what? If you consider the system, so it's T plus F equals to mg. Some are saying this. So it's accelerating also. No, sorry, I forgot here. It's accelerating also. This person is also accelerating. So I will write with the yellow color. That is T plus F minus mg equals to mass times acceleration. Okay. Is it fine, students? So if I consider to be like, let us consider this tension in the rope. Okay, it's tension is basically the friction here. If you consider this equals to this, I'll say like this, कि यहाँ पे what going to happen? Suppose considering the system like this, so I'll put it to be what? Minimize it, okay? So I'll get simple, that is mg plus a. Some students are texting me, force of friction will be equals to mg. No, it's not like this. Same explaining you again if you're having the doubt on this. Initial equilibrium पे tension कितना होता है? mg there. It's m into g. Okay, tension is equals to mg. So I wanted to make that equation again. Okay, let us delete this equation. Hold on. I have to delete this. Yeah, it's fine. So if you solve this question, if students there is some error here, I will give you in the PDF. Don't worry. Okay. Tension when there is no acceleration is equals to mg. But when it is accelerating, friction will also act on this. Okay. So it will be like this, that will write friction value plus what kind of value? Tension value equals to mass times acceleration. Okay, simple. Friction is not opposing it. Friction will be not opposing it. Okay. So you can solve like this. Okay, let us move towards the next question now. I'll give you the solution on the PDF. If there is some error here, okay, let me check it out. This question may, because there is no minus sign. No, the problem is this. See these two answers. I'll say mg plus a and upward direction is the right answer. A is the answer. Those all the students who are given the A is the answer, text me again. Let me see. A is the right answer according to me. Okay. So this, if you'll put, you know, this thing in the equilibrium, the condition of tension was what? F plus. This again is creating problem. There is no minus there. Okay. So we'll say upward plus G plus A. Okay. I'm moving towards the next question. Don't worry. Solve this question. Solve this question, students. Usme minus option, you have to check that question again. That is, there minus option is there or the question is wrong. I'll give you in the PDF. This question I am solving. Just focus, be focused here. A force I plus 4j, मतलब इसके components क्या हैं? 1 Newton here plus 4 Newton y cap. Because this is j cap, this is I cap. Coefficient of friction is this. They are asking us the force of friction will be what? Simple, students. Force of friction कितना होगा? We'll take only the linear case, because if the contact is 0, friction goes 0. Because friction force, the magnitude, you know, no, mu times contact force, normal reaction component of the contact force. If the normal reaction goes 0, friction force is 0. So I will not take this case. I will take only this case, that is back one. ठीक है, हम लेके चलते हैं कि suppose it is not moving up. So I will say like this. We know normal reaction here is what? 10G. Sorry, 10 it is, because 1 into G, 10. So 0.3 into normal reaction will give you the friction value to be 3 Newton. Students, here, the case will be this, that we are getting friction ki maximum value as 3 Newton. And that is also where it's in the linear direction, x-axis, negative x. So we are getting 3 Newton minus I cap as a friction's maximum value. This is a maximum value. I haven't told it's a friction value. Answer is this. No, this is a maximum value. So it means to counter this value, at least we have to apply a force which is greater than this 3 Newton in the opposite direction. And that opposite direction is basically this. So this force, which is our external force, must be at least somewhat greater than 3 Newton. Then only the bonds with this surface will be break, and maybe kinetic friction may come again into play. Okay, but here we can see that the x component is what? If you focus here, x component is here given what? Y की तो बात ही नहीं करनी. We need not have to talk. See, it's not required to talk for y component, j component. X में if we see 1 Newton is the force there. X में what is the force? 1 Newton. ठीक है? So we'll say like this, this force is not sufficient to even move this block. So whatever force we are applying, external, I mean the friction force which will generate on this block in the opposite direction will be same in magnitude. So I will say A is the option. All the students are given A as option. I like, it's very cool. I congratulate them, because this is conceptual based question. Now we have come into the region of concept based. Minus I cap is the answer. Did you understood this thing? Yes or no? So who have texted A option? Let me see in the chat box. Yeah, Jainvi Tumkuru students excellent. Bagalkot good. Devankari good. Okay. Good. What's the note? What's the concept of this? Note is this. Note. Important note. Concept is this. Fs max, which is the statics value, maximum friction, limiting value of the friction. Okay. So maximum value of the static friction, you can call it as limiting value. Limiting. This is a limiting friction, maximum value, limiting value of the friction. Okay. Genuine Balleri student says can't understood. Okay, I'm explaining you. Okay, it is what? It is very much greater than what? Applied external force. So we'll say friction force will be negative. It will be what? If you consider vector, it will be negative of the external applied force. Simple. Here it was 1 I cap. So friction force will be minus 1 I cap. Okay, JNV Balleri students, I'm explaining you the concept of this. What is this? See in this slide. Suppose you're having a platform, and suppose on this platform you are having some, say, block. Which color the black will act? White. Suppose this is a block, or not also acting. Check this. No. This is the block present on this platform. This is a block which is present on this platform. It is having what mass? It is having the mass m here. Take. And suppose the coefficient of static friction value is given as mu s for this context of this block and this surface, and mu k is the value of the coefficient of kinetic friction here. Take. So defined for the surface, I mean the platform where the block is on which the block is present. Suppose I'm applying the force F external on this block. What's the condition? It's for JNV Balleri and all other students who do not understand this concept. What's the condition that the block will move? See, think like this. Suppose if I find the maximum value of the static friction with using mu s, this will, or limiting, this is known as what? Limiting value for friction here, okay? Maximum value of the friction, of considering static coefficient. Mu s into normal reaction. We know this is normal reaction. This will be mg. This will give you mu s mg. This is the max value of the friction which can act. Max value. If suppose R applied F external is less than this F max. Okay, let us take the random values. Suppose F max is 10 Newton. Maximum value. And F external we applied is 1 Newton. Will the block move? Answer is no. Let us say if F max is same, I mean, let us keep it same. F external value, it is same. F max will be same, okay. And external value increase to 2 Newton. Will the block will move? We'll say no. If I increase it to say like this, 5 Newton. Will the block move? No. If I increase it to now say 10 Newton, will the block move? Yes, there are chances. I mean, now the initiation. So we'll say now the bonds between, bonds between the surface platform and the bond between the base of this block, bonds between the atoms of the base of the block and atoms of the platform are now going to break. So this is the breaking point where the contact points will be break and the block is it's going to move now. Okay. But suddenly if I increase my F external value greater than the maximum value of friction, that is 10 Newton, the block will break the bonds and it will move away. So now suddenly what's going to happen when the block will move away and the friction force will be replaced by, as soon as the bond breaks and the block rushes, it speeds up, okay? The friction force will change into this, that is mu k, which is actually, we'll say less than the maximum value. Okay, you can say like this, it is mu s mg. Okay, it's greater than this. It was initial, that's final friction. Mu kmg. Clear? That's why students, when we draw the graph of friction, you might have seen so many times this thing. The graph is like this. How the graph is? It increases and then it becomes constant. Friction value first increases with distance, time also, like it's like this. And it goes constant. Friction is constant. So this I will call it as friction force, which is acting when the block is in motion, that is mu kmg. And this force was what? For mu s. That is friction force for static condition. How much it is? It's increasing. Mu s mg. Understood? Here with the motion, where the bond is break and from where the motion starts. And it's constant force. Did you got it, students? What I'm saying? Is it clear, students? Yes or no? समझ में आ गया फ्रिक्शन कब काइनेटिक और वो सब लगेगा. So according to this question is completed. Okay. Now let us see. Genuine Belarus students, I did it for you. Okay. And for other maybe they have doubt. Okay, but yeah, this question is fine. Solve it, students. Solve the students. Solve this question, students. Any one of you. You want me to solve? They're asking the acceleration of the block moving horizontally is what? Simple. I'll draw the figure. This is force theta. Okay. Let us break the components. This is F sine theta. This will be F cos theta. Normal reaction will be up. This is equals to mg. This friction force. क्या पूछ रहा है? Acceleration of the block. Friction force is mu n. N is this. So if you solve this question, answer is very fine. Okay, answer क्या आएगा? What's the answer is? F cos theta minus mu into n equals to mass into acceleration. So from this you'll get this is n reaction. N क्या होगा first? Normal reaction. Just make the vertical equilibrium. So F sine theta plus n gives you mg. So normal reaction is mg minus F sine theta. Simple, very simple. Speed ठीक है ना students? Anybody is having the doubt? Put this normal reaction in this and you will get mu mg minus F sine theta. This will give you mass times acceleration. ठीक है? Acceleration will be what? Simple, आ जाएगा. क्या आएगा? Anyone? Consider like this will be F cos theta. ठीक है? Upon m minus mu mg minus F sine theta upon m. This will be the acceleration. So answer is C. This will be the answer. Simple. Answer is C, students. Yes or no? Got it? Is it clear? Yes or no, students? Is it clear or not? Okay, cool. Students, this is the last question of today's class. Please solve this properly. This is the end question. I write is at like the end. In cartoons, we see, you know, in Tom and Jerry cartoons, the end. So this is the last question. I mean, 4, but to be continued. Okay. So solve this question. It's on your slide. After 1-2 minutes, I will ask. It's a very interesting question and a good level conceptual question. I'll call solve this question, students. It's on your screen. I hope it's visible. इसको solve करो. क्या आंसर आएगा इससे? I'm giving you 2 minutes to solve. Then we'll end the class. देखो question. Okay, let me explain you somewhat hint. Let me give you the hint. So here what they have given is they are given 2 masses. This is B mass. You know the mass is given as what here? It's 5 kg. And this is connected. If you see it, See, I'm back again. Okay. On the other end, it is connected with this block. ठीक है? So you have to find here that what must be the mass of this C block. Mass of this C block कितना होना चाहिए? Such what must be the mass value magnitude such that all the system is in equilibrium. I mean, nothing is moving, nothing is accelerating, nothing is moving, even with the constant speed. Yeah. Valerie, right answer. No, it's not right answer, I think so. C. Okay, let us see the answer. Okay, I'm solving it. I'm solving it in front of you. Just watch it carefully, fast. And then we'll end the class. So see, this was the scene here. This is a big block and it's having the mass as A. It's equals to 10 kg. And we're having a mass, small m. I don't know what it is. It's asking the question. What's the answer of this? And going over the pulley, the string is connected with some other block, which is having the mass as 5 kg. Okay. And friction coefficient of A with the table is given as this. So this mu, here is given as 0.2 and it's static, of course. If not given, it's static, we can feel it. Minimum mass of M they're asking. So the condition will be this, students, ki if you draw the FBDs, if I draw the FBD of this, I'll get like this. Tension force will be here, every percent, because there is one string. So in one string, tension remains same. So this is mass F, 5. So I will say tension is equals to 5 into G, mg, that is 50. So tension I will get here 50 Newton. Okay. Here also the same tension will be there. And I have to keep the system at rest. So I will say here, if I draw the FBD of this complete system ka matlab kya? Complete system, considering this both the blocks as system, if I draw the FBD, I'll get this answer, that is tension in front will be equals to the friction. That is, this value comes out to be tension equals to complete mass of the system, okay, into G. This will give you the normal reaction of the complete system. And a normal reaction of the complete system into coefficient of friction, which is basically nothing but 0.2. So solve this, put tension value here. So when you put tension value here, that is equals to basically 50 Newton. Yeah, one student have texted me something. Okay, Devankari, let us see C is the option or not. 50 Newton becomes equals to mu, that is 0.2 into complete mass into G. 10 plus M into G, that is 10 will. Let us solve this. This is 10. 10 gets cancelled. Point could remove, I have removed the point. No. This is 25. So 25 becomes equals to 10 plus M. This is the minimum condition to find the minimum mass. M, this is the condition to find the minimum mass value. Okay, minimum value of the mass M of the C block, which is to be kept on this block A connected with the pulley to the B block. This comes. So 25 minus 10, I think we got the answer. It is what? 15, because 15 plus 10 is what? 25. So this is our answer. Mass comes out to be 15 kg. Okay? So if we check, A is the option. A is the option. A is the option. So how many students got this right answer? Conceptual. Tumkuru, good. Beleri, no. Tumkuru, good. Mariha has given the right answer. Okay. Now I have understood. Now I think all of you students got the solution cleared. Is the solution clear to you, students? Yes or no? Is this solution fine? Yes or no? Solution fine? Okay. So students, this is one of the last question. 3 minutes are remaining. 3 minutes are remaining. I'll solve it. I'm not asking from you to solve. Okay. I'll be solving this question. Be focused. Be focused here. Okay. It's very simple question. Last 3 minutes. Please. Okay. Have patience. Have patience. So see, I'll solve this question on this slide only. Okay. This question, what it's saying is this: you have to find the friction. No. They're asking us if this block is kept on this. You have seen the conveyor belts; these are moving like this, like this. Okay. So this belt is moving like this, and they say that what must be the minimum velocity should be the block be projected. So what must be this V naught minimum value such that it just reaches from left end A to the other end B, such that on the other end of the bead conveyor belt, moving with constant velocity V, friction. Okay. So it is asking us what must be the minimum velocity of this block of mass M, such that when it is projected from left end A towards end B, it reaches on the other end of the conveyor belt, moving with constant velocity V. It must reach. Simple as students. What apply here? Energy conservation law. Work done. Apply here work done law. So what it says, we'll write here like this, that work done by the friction on this block. See, L is the length which this block has to pass to go from left end A to the other end B. So I will say work done by friction. Friction kitna lag raha hai? This is normal reaction mg. Friction force is how much here? Mu times n, that is mu mg. So I will say work done by this friction force must be at least equal to what? Kinetic energy of this block. Simple. Okay? So applying that energy laws here. So I will say here work done by friction. Kitna hoga? Simple. F negative because it's negative, but we'll take the magnitudes. Okay. Friction ka work done. Work done क्या होता है? Force into displacement. Displacement is L. Left end से B, other end तक. And this is equals to half mv naught square. Okay. Friction force is how much? Mu times normal reaction, half mv. These are the least conditions. So solve करोगे, you'll get 2 mu gl as v naught speed. This is the answer, students. समझ में आ गया? Is it clear? So we'll say V naught answer will be this B. Okay. So students, that was all about today's class. I hope you enjoyed the class. If anybody is facing any doubts, can ask now, or we can leave the class. Okay, because time is up. Time is up. No. Okay. Bye bye everyone. Take care. Study well. Be happy. Be happy always. So practice HCV numericals. Start with HCV. If you are very much interested in physics, if you want to explore the thing, you want to be champion in the questions, you can solve IE irradiative books also. You can solve IE irradiative, okay, but that's an extra level. It's it's more than G, I think. Advanced you can do for confidence. And when you crack mains, you can go for advanced. Bye everyone. Bye, Madhya. Bye, Devangiri students. Bye everyone. Take care. Study well. Time is up. Okay. So we're ending it here. Bye bye. Bye everyone.